Hey everyone, welcome to the System Design Kata of the day. And today we're going to talk about designing a real-time collaborative editor like Google Docs. So when you tackle designing a system like this, there are a few questions that you should keep in mind. First, how do users interact in real time? How are conflicting edits resolved? How do we store changes at scale? How do we keep performance global? And how do we recover when things fail? We are going to answer these questions by thinking about the main layers that this system would have. First, we have the communication model. This answers the question, how do users see each other's edits? So here we're going to start with WebSockets for persistent bidirectional messaging. Each client joins a doc-specific channel, and when one user edits, the server broadcasts that change to all others. But why WebSockets? HTTP is stateless, and polling is slow. So WebSockets are fast, efficient, and keep the connection open. We could also fall back to server-sent events and HTTP long polling when WebSockets fail. Now, here, the main thing to keep in mind is that this is a UX first choice and not just a tech pick. The next layer we're going to discuss is conflict resolution. And this answers the question, what happens when two users edit the same content? Here, we can use operational transformation for intent-aware syncing, or we can use CRDTs for decentralized eventual consistency. In here, we have to also include the view history with timestamps and also the edit intent ordering with the application of the differences. The next layer that we have to consider when designing this is the persistence and storage layer. And here we're going to use a sharded non-SQL database like MongoDB. We're going to shard on document ID and we're going to replicate for durability. Now, very important that we log the changes with a write-ahead log or event stream, and that we store snapshots in object storage like S3 or Azure Blob, and that we use Redis for recent edit caching. Now, you've got a system that supports high write throughput, versioning, and fault tolerance. So then we have another question to answer. How do we keep performance fast everywhere? And here we're going to discuss our edge delivery layer, in which we're going to use CDNs for static files. We're going to cache snapshots for near users, and we're going to apply lazy loading for long documents. And the lesson here is that initial loads matter and perceived performance is equal to user trust. Finally, we're going to talk about graceful degradation, which answers the question, what happens when things break? And here we are going to design for failure, allowing offline editing with local storage and using polling as fallback if WebSocket fails, and also sync queue and reconciliation on reconnect. And of course, we need to keep the users aware of what's going on by using alerts such as offline, unsync, etc. So what we're saying here is systems fail, but users should never lose work or feel abandoned. Now that you have seen the layers, I want you to challenge yourself. First, if a hiring manager or client asked you to ship a working demo in 48 hours, what's your plan of attack? What tech stack would you choose and why? We know that design trade-offs are inevitable. So which of these layers would you spend the most time justifying to a client or project manager? Have you ever worked on a system with real-time collaboration, multi-user sync, or high write load scaling? What were your biggest lessons learned here? And how would you represent this design as an architectural diagram using Azure, AWS, or GCP services? And finally, how would you break down this architecture to a new hire or junior engineer to help them understand distributed collaboration.